Good morning, Dr. Caps, and welcome to my lab for the final time. Today we will be making water that has been cooled past freezing point freeze on command, which is kind of a neat little trick. The reason that this happens and what I've been able to research is that freezing isn't just getting to a certain temperature, but there's also a certain level of energy input required to achieve a state of matter change. And that is sort of the reason why this water is probably below the temperature of freezing, but still requires a little bit of extra energy to freeze on command. Or if it were to leave it in the freezer, it would just freeze due to there just being its temperature being lowered to a sufficient level where the amount of energy required to freeze would be very minuscule. So without further ado, let me go grab my water bottles and we will see this in action. All right, in my first experiment, we'll be using one of these bottles of water. I'm using the exact same one that he uses in the video. Maybe not the same brand, but the same size, and I've frozen it to the exact same amount of time that he told me to. And so the energy input that we will be giving this is a little smack. And this will allow the water, which is cooled past its freezing point, it will allow it to freeze instantly, well, mostly instantly, because of the energy input that we have given it. So here we go. There, you can see it's starting to crystallize. It's kind of hard to see, but you can sort of see it getting a little foggier, and that is the water within sort of freezing pretty instantly. Sure, and I think we'll demonstrate this in a few other ways. All right, here we can see I filled the glass with some of our super cooled water, and I have this ice cube here, and I'm just gonna drop this in, and you'll see that it will freeze the water pretty instantly. This is, the reason that this works is not so much an energy input, but more of the fact that you're sort of, the ice cube is allowing all of the water molecules to align and freeze, sort of giving it sort of a boost, if you will, into freezing. As you can see, all the water around it has frozen. Woo. All right, one of the final ways that I'm going to demonstrate this principle is by using this super cooled water and this ice that is already in the, it's in the form of solid. And I'm gonna pour this water on top of the ice, which will allow this super cooled water to instantly form ice, because the ice is allowing the molecules within the super cooled water to align themselves in a way that is more solid, sort of allowing for an instantaneous phase transition. Pretty neat stuff here. To be honest, I was unsure if this experiment would work, and I am pleasantly surprised. So, like I said, the water is cooled past its freezing point, but it is still in the form of water because it requires a little extra energy to change into ice. And the ice here allows it to sort of almost bypass that. It sort of helps slingshot, I don't know how to describe it, to be honest. Sort of helps the ice, or helps the water align itself into a solid form, help it crystallize a little bit. And helps it, and that allows it to become ice instantly. So that is my video. Thank you for a good semester, Dr. Caps. It's been a great time. And what better way to end it than with an ice cold glass of water. Thank you.